Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking, write behavioral Vhdl models for the following. Here this question is asking 8-bit register shown in figure 4.1. This 8-bit register, we are going to write the behavioral Vhdl model for this one. Okay, now let's see how it is. Here we are going to use the std logic, so we had to import the library IEEE. Then from this one we had to use IEEE std underscore logic underscore 1164 dot all, and the entity here, based on whatever the name given to this, that's the name we had used for entity. Here it is 8-bit register, so I'm going to use that one, 8 underscore bit underscore register is, then port. Here we put the input and outputs. Here you can see obviously LE, load enabled, and clock are inputs. So clock right here and load enabled are input std logic, and after that we have d in, that's an 8-bit d in, that's an input. So d in, that's an input, so in std underscore logic underscore vector, and this is 8-bit, so it's going to be 720. Then d out also 8-bit, so here we are going to have d out, this is out, std underscore logic underscore vector 720. Then after that we are going to end 8-bit register, then after that architecture behavioral, the same name, this same name should be here, behavioral std behavioral of, because whenever I use behavioral we had to use of, because after of the name should come. After of the same name, 8-bit register, 8-bit register is now begin process. First clock, LE and clear will be activated. From the table you can see that these are the three things we necessarily need. Then from this one we are going to say if clear is equal to 0, here you can see, here we have 0 0 and here don't care, so regardless of whatever it is, there's no change. So if clear is 0, then the whole thing is 0. Then we can say d out is less than or equal to, here d capital out less than or equal to 0, 8-bit 0 0 0 0. Okay, now after that else if clock event and clock is equal to 1, clock is equal to 1, then if load enabled, so also 1. If load enable is equal to 1, then here you can see clear is 0, and if the load enable is 1, else if mean first we use, if the clear is 0, this is going to print out. Else if mean clear is 1, so it's going to go to the next one. If the clear is 1, then it's going to check whether the clock is 1. If the clock is 1, then load enable also 1, then it means load D in into register. So D in into register, if we put D in into register, it means it's going to be the same thing as D out. So from this one we can say D out is equal to D in. Then after that, let's continue here. After that, else null end if end process and end behavioral. Okay, that's it. And that's the code. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn VHDL programming, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.